Hello, everybody. This is Kubernetes Workgroup Device Management meeting for August 19th, 2025. And let's get started. I will share the agenda. Okay. All right. So I just took a bunch of old things that were, well, things that were listed in the future meeting agenda and put it in here. So there's a bunch of things here. I'm not sure if people are actually ready to talk about them. So I guess we'll find out. Sergey, are you here? And did you want to discuss this today? Just looking.
I don't see him on the list.
Okay. So let's skip that. Morton.
Yeah. Oh, second. Okay. Yeah, I added this a while ago. We have added quite a lot of features to the array, and several of them require specific changes to the drivers. And I think today it's both hard for authors of drivers to know what is needed to support each feature, and for users who want to install these drivers in their clusters, it's hard to know which driver supports which features. And if I'm using several drivers in my clusters, like which features are actually ready to be used and which one will perhaps fail in strange ways if I try to use them. And do we need some kind of, or at least I think about a system for addressing both problems, like how do we make sure authors know about new things, and how can we give users guidance when they start using these?
Okay, Patrick.
Well, the first one I think is easy. If the array driver authors are happy with the array as it works, they don't need to know about new features. We may do some outreach and communicate improvements somehow, perhaps a blog post, release notes, but I think we are already doing that. But beyond that, I'm not sure whether we need to inform the array driver authors even more. And then for users, well, our APIs are designed so that if they use an API, they know that it's supported. None of these prioritized list partitionable devices, mix-ins, consumable capacity. Well, consumable capacity perhaps is user-facing to some extent, but these are parts that are in the API. We don't need to tell a user that a certain driver is using a partitionable device under the hood, in my opinion. That's, for users, almost an implementation detail.
Yeah, so I would agree with that. So even with like consumable capacity, right? If you say you request 10 gigs and nothing supports consumable capacity at a driver level, it'll just be treated as has at least 10 gigs, which is right. So semantically, like it's equivalent to a cell expression in that case. So I think that the point is like separating those two pretty much falls along resource slice versus resource claim. So resource claim being the user-facing API, everything there should work regardless of what drivers you have installed. Now, it's true that like if you put a match attribute constraint on something, you need to make sure that the drivers publish that attribute, right? So there are some things like that. But I don't think most of any of the resource claim user-facing have a direct dependency on drivers implementing some feature. They just change what the user is asking for. I do think I think it might be useful to to have a sort of best practice for driver authors where we say, hey, here's a table or a list of bullets. Look this over, see if any of these features are useful for you, and any that are, if you implement them, put a note in your documentation that says, hey, we're using this feature, it's in an alpha state, a beta state, or whatever, here's the feature gate. At least so that, I think probably people are doing this already, but like if we provide an example, it might provide a kind of consistent way to report that information that'll make it a little easier for users. But beyond that, I'm not sure what we can do. What do you think, Morten?
Well, can I jump in here real quick? Sorry.
Oh, sure. I didn't see the hands. Sorry.
No, it's fine. Yeah. One thing I wanted to just follow on to what you just said is that at least in the NVIDIA driver, we recently added feature gates. And so you can turn on and off certain features based on that. It's something we should probably backport to the example driver so that we're also doing it consistently there. But the other thing I just wanted to say, touching on the idea of do the drivers implement prioritized list, partitionable devices, mix-ins, all this stuff. I see those more as mechanisms to enable a higher level feature, right? Like no one actually cares if the DRA driver for GPUs uses partitionable devices. What they care about is, can I allocate a MIG device dynamically, right? So that's the feature that they care about. How we actually implement that isn't really that important to the end user, right? But to your point, I do agree that driver implementers, it'd be good if they had a centralized place. They could look at what are these features, what types of things do they enable, and how could I make use of this for implementing my driver to advertise the types of devices that I want people to be able to get access to. And then related to that, maybe this is something that can be piggybacked on the second to last bullet point here with this page that Kevin Hannon's putting together. It's obviously important to have vendor specific documentation, but a centralized place where the drivers are listed that say, a good example like what you brought up before, on that page, it'd probably be good to have some reference to the fact that DRANet and the DRA driver for GPUs both publish the PCIe root standard attribute so that people know they can link on that in the match attributes and things like that. So yeah, maybe we should be thinking about it in terms of what things should we have in vendor specific documentation versus this centralized place that's listing the device vendors themselves.
Yeah, I think that makes sense. And this came partly because of the prioritized list, because it's had like this, we had a subtle thing in that the status reference to the request might include like a slash and a request sub-request sort of format, would mean that for that particular feature, the driver actually needs to support it. Otherwise, you can get unexpected results. But I agree, that might be an exception for mostly others, like mixin and partitionable. I agree, that's probably not true. In that case, it doesn't impact the user. So
you're saying since we don't pass through because the driver fetches the claims on its own, it has to link up from the ID and the allocation to the specific sub request, and so it has to be aware of sub requests. Is that what you're saying?
Yes, if you use the feature, it has to sort of parse the request reference in the status of the resource claim. And I think we're doing something similar, if I remember correctly, with I can't remember if consumable or device binding with the index. I think
share.
I seem to remember.
Yeah,
we're doing something somewhat similar there, which I think I know less about those features, but I remember from reviewing.
For the sub-resource one, I think we put that behind the helper in Patrick's library that he has in the Kubernetes staging repo.
One or the sub-resource one? The
sub-resource one, so that so that the driver implementers don't have to care about it. But I'm not even sure what the second one you're talking about is. Was this one one of the most recent changes with? Did you say with the bind?
So with consumable capacity, right? So you're taking a
Mhm.
single device, and I don't think it's something you would necessarily support in your current GPU drivers, but think about a NIC, and a NIC has you could take a physical NIC and you could create bandwidth constrained virtual interfaces on top of that. And so consumable capacity lets you do that, but in order to make that work, it generates a share ID that uniquely refers to that sub device, that share
Mhm.
that share of the device. And so for example, actually Praveen and I were talking yesterday, and he had his CPU driver, and when he uses consumable capacity, he saw something not quite hooking up. And I suspect that might be related because he's probably not taking the share ID into account. So there likely are some things with some of these new features where the drivers have to think about it. Maybe we could build it into some helpers. That would be ideal. But we can look more closely at that.
I think putting into the helpers is good, but that sort of still, with the user still don't know which version of the helper the driver was built against, so you can't really tell if it has the feature included or not.
So probably what we need to do, and just I want to time box this because we're already 15 minutes in, but what we probably need to do is in our caps, we need to start to specifically note whether driver changes are needed to support that functionality. And then that's one thing. And then the second thing is I agree with Kevin Clues that we should use Kevin Hannon's page to probably track in those cases where some driver support is needed in order for the feature to work, whether they support it or not in any given version, as much as we can in a central place. But yeah. Kevin Hannon.
Yeah, I just drafted something. I'm not even sure if that was the right place to put it, but I did try to start, like, I was hoping we could have something in Kubernetes website, but I guess there's a lot of pushback on having any vendor specific stuff. And I know there was one question about whether or not it could be a blog. I feel that this is I think we're gonna need like a real-time page that we're not real time, but we're probably gonna be updating this over time. So I think having like I'm open to wherever you all want to put it. I just
Can you ask the I don't know if it's Contribex or if it's documentation or whoever about putting it in the workgroup device management section of or maybe the SIG-Node section of the community site, because that particular K-SIGs repo you've got there, like that's for us to like try out random stuff and like put random code that's not supported in any way. And I don't really want to direct users to that. It's kind of our own just scratch pad.
Well, I mean that's fair. I think generally it sounds like our pattern is users should be reading their vendor docs, right?
Generally, yes.
So like I don't know if we ever really want users looking at this page. It's more for us.
That's a fair point. Yeah.
And I mean that's why I put it there, to at least have a place, because I was just trying to look at like where NVIDIA, AMD, Google, and R, and I'm having a hard time finding all the drivers for these anyway. And like I just started with like links of where the DRA drivers are. I do think features of device, or sorry, DRA features and the DRI drivers would be good to also have, but I don't know when we want to track that. Like prioritized lists make sense and structured parameters, but something like partitionable devices, I don't think there's probably any device vendor that has support for that feature yet, right?
I don't know, Kevin, have you guys implemented it?
We haven't yet, no.
Yeah, we haven't either.
So like it gets kind of like, when do we start tracking that? Because like I can have a page of like structured parameters, and I imagine everybody who has a DRA driver is probably supporting that. But then I have to dive more deep into each of these drivers, which is not really able to do at this time. But I guess
Okay.
comment on the issue or the PR I have, and we can figure out maybe a better place for it. I just
Well,
saw something that looked obvious to me.
Yeah, your point that this isn't for users actually kind of that makes it more appropriate here, but we can discuss on the issue. Okay, awesome. We kind of jumped the line there. Is Peter here? Sounds like.
Hello, I'm here.
All right, you're next on the agenda here.
Hey, yeah. So this is mostly a notification for any CAP authors in the 135 timeline. Red Hat has some extra capacity, and we wanted to devote some energy into DRA. However, we're able to. So I have some folks who might be reaching out to CAP authors and offering help. And so if there's anything that we could direct our attention to, would be happy to do that, or we can just have it, however it aligns. But yeah,
That sounds awesome. I started, and I'm not ready to talk about it here yet because I didn't make the updates. I started a version of this, and there are probably new caps that we haven't talked about yet. That sounds awesome. We'll get that started really soon. It looks like Rita's
great. Yeah. Yep. And we'll be paying attention to that. And folks will be reaching out and volunteering hopefully soon. So,
fantastic.
Awesome.
Thank you, Peter. Rita?
Sorry, I should have chimed in earlier. This is kind of related to the previous topic.
That's fine.
I added some things in the chat, but maybe y'all are not following. But basically, just listening in, I was curious if there's been any discussions prior about having some type of conformance for DRA. I think we kind of discussed this, but it was like very quickly, right? And especially since y'all were talking about vendor specific status across these different features. So I'm kind of curious if that could be helpful here. And I linked to some stuff to like the Gateway API project. They've done a really good job. I think they've done a good job of setting up like the criteria, submitting conformance, and as a user, right, it's pretty easy for me to go to that link and see what vendor implements what and what status they're at. Again, this is not really Kubernetes website. But I think having something like this where users can look up the information would be helpful.
Just for DRA drivers, if they're conformant to everything, is that the idea?
Yeah, conformant to the DRA like features, I guess.
Yeah. So in the first, I haven't been to the second. I didn't go to the third one. I don't know. One of the AI conformance working group meetings, this kind of came up, and I think you were there, Rita. So we probably had that discussion there. Like, I think we should do something like that, and especially as we have things like standardized attributes, we can have it where you either need to say it's not applicable because they're not necessarily applicable to you, or if they are applicable, then you should be supporting those standard attributes. I'm not sure what else is needed. I mean, there'd be like, we report health status, I guess. Is that so? I think if somebody wants to pick this up and start to try and put together a set of criteria, one of the things we talked about in that AI conformance working group was rather than making the criteria part of that program, it would be more like that program would have a one-liner that says like the DRA drivers you use should be conforming according to this. So like we'll need that program if they're gonna rely on it too.
Right. And I do feel like if it's a DRA conformance, this is the right group to talk about it. So I guess I'm trying to get a sense of, is this useful to people, right? Like both as the driver implementers as well as the users.
I mean, I don't know. I can't speak for other people. I think it would be useful. At least, I don't know what the criteria are going to be and how in depth they're going to be, but at least to be able to say things like, yes, this driver supports, the standard attributes. I think is helpful. Swati?
Yeah, I just wanted to say on the previous topic itself that we for the vendor list of for the list of vendors of DRA driver, we can have a section on the example driver itself. It used to be similar for device plugins also, that you would see a list of all the vendor specific device plugin implementations. So right now, as Kevin Hennon was saying, that it's really hard to find out which vendors have driver specific implementation. So maybe we can just, instead of having like a proper list somewhere, we can just dedicate a section in the README to example driver, where every vendor can have a list and specify what are the features supported for this particular driver.
That's a possibility. Why don't you comment on Kevin's PR there?
Where is it listed?
This one here. So he has a PR with that page in a different repo, but
Okay,
if you
perfect.
want to comment and suggest putting it in the README, we can discuss it there.
Yeah.
Unless, yeah,
Okay, perfect. Thank you.
I don't have a strong opinion about it personally.
Yeah, I mean, if we are just trying to find a place, example driver is a good place. Just dedicate a section of README, and then everybody can see these are the vendor specific implementations with the list of features that they are supporting.
Okay. All right, good idea. Okay, so before we close Rita's topic, is there anybody we can put as taking a lead on putting together a conformance program for DRA drivers? Anybody interested in picking that up?
How about as a start, I can start a chat in the working group Slack channel just to see how many people are interested. I don't think we should spend too much time unless people see enough value from it, if that makes sense.
Yeah, I mean, I definitely see value from it. I think we should try and make sure that a conformant driver has, health updates, all these things to make sure that, I think that's the biggest one, is making sure that they're, even more so than does it expose the PCI root attribute. It's things like reporting health status and things like this that I think
Yeah,
you would need to ensure a driver has in order to be conformant.
absolutely. Like the must-haves versus like nice.
The must-haves, yeah.
Yeah. Okay.
So yeah, so starting a channel, a thread in the Slack channel seems like a good place to start, and then maybe some of the people that Peter was talking about can jump in and start moving that forward.
Yeah, I could be interested in that.
Okay,
Awesome.
sounds good.
Awesome. Okay, Ruhi?
Hi. So this is regarding the DRA cell constraints cap. We've had some discussions in previous meetings about the scalability concerns. And after thinking about it more, we would like to propose that we switch back to the original approach of match expression, where the cell expression will be evaluated monotonically, exactly like how match attribute does it as well. So instead of evaluating the cell expression after the complete device set is populated, we would evaluate it after each device is added to the set. So we think that this would address the scalability concern, since the scalability envelope doesn't change in that case. It would be the same as match attribute.
Is it what I'm trying to understand? So are you saying this? There's the semantics and there's the implementation, right? So when you say match expression, the match there implies that the semantic is the same as the match attribute, meaning that just rather than reading a static attribute value, you calculate an expression, and then you check if the value of that expression is the same as the value of that expression for the other devices in the match.
Not really the value of the expression. So it would result to a Boolean value. So I guess, yeah, we would check.
It's not a match expression. It's still, all you're doing is changing semantically. What you're doing is equivalent to evaluating the set at the end, but it's just you're doing it incrementally. So I would still actually just call it expression. You're just changing how
Okay.
you implement it, as far as I
Okay.
can tell.
Yeah,
Like, wait, do you see how those are two totally different
Yeah.
operations, right? They're two
Yeah,
totally
yeah.
different constraints. And so I don't think we have a need, from what I've been gathered based on the previous discussions, for the match expression. We just have a need for, hey, only include this device if the expression evaluates to true.
Okay,
And that's a different thing. Yeah.
okay.
Make
Sure, yeah,
sense?
we can keep the original API format, so cell expression. But yeah, this would just be evaluated monotonically, so after every device is added to the set, instead of all at once at the very end.
Right.
Sorry, John,
So
can you explain the distinction again? So how is this different? If in what you just said, it sounded like selection to me. So I don't understand how it's different than just selecting a device.
so they're both just selection, but they're different.
Mhm.
They're different algorithms, right? So if you just say an expression, and the expression needs to evaluate to true, that expression could do anything, right? So it's going to take the way that I understand, like the specific use case here is you're trying to add a device to the existing set. You're going to evaluate an expression that's going to look at all the devices in the set and sort of see if these are contiguous ring series, a contiguous set of IDs. And if it's not, it'll reject it, and then that device is rejected. The match expressions, the algorithm is calculate a value for each device, and they all must be identical. It's just a different algorithm, right? And
so that's the one I thought we were. That's the one I thought we were building. At
that's
least the way I understood this
very
initially.
originally thought we wanted, and that's what I'm saying. Don't call it match expression unless it's that. Call it something different, and that's what we're doing. We're calling it just expression or cell expression or something like that. Right? So there's multiple ways you can define a constraint using an expression, and these are two totally different types of constraint. Do you need a match expression for something? Because I think it was AWS. It was most interesting.
Yeah, I'm not sure, but I think so. So let me make sure that let me reword it to make sure I understand. Okay. So I have my selection criteria that might match, say, 10 devices, and this constraint would then help me narrow that down to exactly one, or is it?
No. This is like match attribute. It's for sets of devices. Right. So if you have multiple devices that may be from separate requests, you want to choose only ones that have an identical value for the attribute. Match expression would say, instead of just using a static attribute, calculate an expression for each of those devices.
Sure, I understand match.
And then the one that we're talking about,
still don't understand. Yeah, exactly. Yeah,
the one that we're talking about implementing would for each device, it executes. Well, really, the original or the what's written in the CAP right now is at the end when it comes up with a set of devices, it evaluates the expression once and passes in the whole set. And then that expression can do whatever it wants to return a Boolean value of whether that set is valid or not.
So I'm still confused. So are we now keeping the same cell semantic of passing in a set of devices? Is that goal, and we just evaluate more often?
I think that's what Ruhi is suggesting.
Yeah.
So let me play devil's advocate. Nothing prevents a user from writing a cell expression that takes the whole set of devices and always returns true unless it has a full set. And then you have the same problem that you have right now, where we need to iterate over all possible combinations of devices, and the complexity is the same that was raised as a concern earlier. You can write cell expressions that really do pruning of a search tree, but nothing requires the user to do that. So the worst case is still as bad as it was when this was proposed for 134.
That's true.
Yeah, I see. Okay.
I think we should, I'm not sure that this is the right way to solve your problem. Like, I think we should maybe go back, take a step back and say, okay, as I understand the problem, right, it's this, you want things allocated in contiguous sets.
Mhm.
And so, I don't love putting it on the user anyway. I'd love that to be built into your driver. Partitionable devices isn't the right solution for that either, probably, because in partitionable devices, you'd need to enumerate all possible sets a priori up front.
Mhm.
But we have some similar problems in our multi-node cases where we have, and frankly, NVIDIA has similar problems with like compute domain, where like it's a switched fabric, but you might want to take a combination out of the subset. Or in the TPU case, we have also like these toroidal topologies. Like, maybe we start a Slack channel on this, and we start to think about some of these problems, see how we can solve them. One of the things I've been thinking about is what I would call a provisioning flow rather than an enumeration flow, where we bake in the kind of rules for what can be validly provisioned. It may or may not fit here, or it may partially fit. So I think we should kind of go back to the drawing table, and maybe an expression constraint after the fact written by the user isn't the right way to solve this problem.
Okay.
So one of the other thoughts we had is to have a DFS-like approach. So every device declares its neighbors through attributes, and then the UX goes on to say, I want connected devices, and DFS is baked into the DRA side of things. So it runs a DFS on the set of devices. But we didn't propose it today because we thought this might be a shorter path. But if we are open to going back to drawing board and starting over, then that might be another
think
thought to
we're
go.
going to get a better result if we do that. Yeah.
Okay. All right.
So that would end up needing to be some kind of standard attribute that then we ran some custom algorithm over.
Yeah.
That's something like that. So we had a similar idea around the alignment piece. Like right now, we force users to use this match attributes to do alignment, and we don't really love that. Like we've talked about publishing bit strings that represent adjacencies, and then just being able to say require alignment or don't. And if it's not, we still try to optimize alignment. So I think there's a nest of problems here where we want more sophisticated algorithms like hidden from the user and built in. And I think we should start a discussion around that.
Okay. I guess as a follow-up, we will capture this thought, like the UX around what we were thinking with is connected, and maybe post on the Slack channel, and we'll take it from there.
Awesome. That sounds great.
Thank you.
And Geeta, it looks like you're...
Yeah, we still have one more item. So this one, I think Kevin answered my question. So if you click on the issue, there is currently a gap around how to consume partitionable devices from things like leader worker set and job set. And John, you have that issue you have opened, which is exactly what we want also. I wanted to bring this up here to see if we have picked a direction on it, so we can maybe just get behind that instead of exploring this all over again. And I see a comment that workload aware scheduling might be the effort to contribute towards if we want to see this, but we want to bring it up to see if people have thoughts.
A lot of us have a lot of thoughts. So I see Dominic's on here. So workload aware scheduling is kind of a bigger thing, and there's a doc out there if you haven't seen it that discusses a lot of that, and that's bigger. That's more SIG scheduling scope. Like it's probably not the right place to talk about it here because we wouldn't have all the right people, although we seem to have several of them. And we can take some time for it if we want. As far as the specific, so tactically, I was like, if we look at job set and we look at leader worker set and we look at other places where we at least for all of us with multi-host use cases, where we want to use DRA to model those multi-host logical devices. We want to instantiate those on a per workload basis. And so, yes, ultimately we can solve that in the workload aware scheduling, but that's like a much longer process. Like more tactically, we have certain workload controllers that are used for these use cases frequently now. And so like in the job set case, the idea was, hey, I want to provision a TPU slice, which is say a 16 node device, for each of these jobs. I have a job that's got 16 pods in it, and every time you instantiate a new one of these jobs, I need to instantiate a new TPU slice. And so I want resource claim templates not at the pod level, but at the replicated job level in job set. So that's what I'm proposing there. And then leader worker set, we have a similar thing where we want to instantiate one of these devices. And it's not just instantiate, right? You have to instantiate it, and then you have to go into the actual pod spec of that job, and you have to point each of those pods at that same instantiated resource claim, not the resource claim template, but the resource claim that's instantiated from the template. So that's kind of the flow and the support in say job set or leader worker set.
I think what they're asking here, though, is there a way to avoid that? So that you don't have to do this on a per workload definition basis. So you don't have to update job, one by one, job set, then leader worker set, then wherever.
Is that what the question is?
There is, like, if we have concluded, if this has been discussed before and we have concluded that let's just update the workload definitions, then we might just contribute towards that. But if we want to see how to enable all of them by doing something on the array side, maybe we can explore that. I don't know the context, background context on it.
Right.
Like MPI job is another one, right? Kevin called it out in that other issue.
So I love some ideas. I think that the problem is the actual definition of how those resource claims should be created may be workload controller dependent. So leader worker set, so one question with leader worker set, and if Kevin Hannon might be able to explain this better than me, like if we implemented it at the stateful set level, like I've been told that would be insufficient for leader worker set, because in leader worker set, the shared device may span multiple stateful sets, right? So that's a very leader worker set specific type of logic. And so I'm concerned that there may not be a generic way to implement it apart from the workload some definition of groups of pods or something that workload aware scheduling may implement. Kevin, I see you have a hand, so maybe you can.
Yeah, I'm just gonna agree with what Abdullah, because this conversation came up a bunch or a little bit in job set where, you can envision it's sort of like a Russian doll where you have a job set and a job, then pods. Each job can schedule the resource claims and have all those pods share that one. And then you have multiple replicas of those jobs. And the same thing for leader worker set, but then there comes a problem where what if you want all your stateful sets or all your replicated jobs to share the same resource claim? And then you end up having like the top level API. And I mean, it gets hard to really rationalize how we would implement this, because like even for job set, like how does this work if we do have this API at the job level? Because then we kind of have I don't have a great answer there, but I have a feeling that we're gonna have workloads will kind of need these APIs. There might be I'm thinking of the Kubeflow trainer case where maybe they have certain jobs that don't actually need they need this specific claim, and then the rest of the jobs could use a different claim, but then all these different jobs are shared together, and that it kind of gets complicated really quick. And so I think I agree with John on this one that like workloads make sense to define what you need. The one thing I always get a little confused on is how do you know, like if someone creates a job or a job set and they want to reference the same claim, like do we have like a hard limit on the claim? Like how many pods can actually reference that claim?
We do. It's
Yeah.
I think 256 right now, but we have a cap there to break that, but we haven't figured out how to implement it yet. It's
So
called
it would be
reserved for workloads is the cap.
okay.
That says, okay, because right now we list every single pod in the claim that's using that claim, and so we can't list 2,000 pods. It's not reasonable. So we limited it to 256, I think it is, and that's not sufficient for all of our use cases, at least at Google. And so one of the things we proposed, but we weren't able to make progress on in 134 is reserved for workload. So rather than saying it's reserved for these pods, that's the field name reserved for, rather than saying here's the list of pods, and actually the API already supports this. You could say it's reserved for deployment. We just don't know what to do with that in the actual implementation, so it doesn't do anything. Or maybe the validation stops it. I'm not sure. Patrick could say for sure. But like the API theoretically supports reserved for a deployment, reserved for a job, reserved for whatever, and then we could actually have that job be of whatever size we want, and we wouldn't have a limitation.
Yeah, I guess maybe I was explaining this to someone in the Kubeflow community, and I guess what I get confused on is like what's going to be the majority of the use case would be like a GPU. Well, I'm sorry, with Blackwell these things get more complicated, but for like an A100 and H100, I'm imagining like a GPU must be on that node. So like I have like a much stricter limit, but then if you have this case where a job set is sharing, you also have like the device vendors themselves will need to support that, and that's where I get a little confused on.
There's also the network attached devices or non-node local devices, and then it could be across different nodes.
That's where,
and then that's when it gets that's when that number can grow a lot, because now each pod on a different node could potentially be pointing at the same non-node local resource claim.
Yeah, and so that's where like with the API, I get a little confused on like what is possible to do right now with like, as people are looking at DRA, I think I'm encouraging them mostly. It would probably be a node local device if they have like A100s, right? Or H100s, but for newer GPU models, we might have more advanced sharing.
So that's the cutting edge, right? And we have a few different caps related to it, and I'm probably going to propose at least one or two more this coming cycle. Whether we'll be able to make progress on them or not, I don't know. But it's it is something, at least for me, I'm looking at pretty closely, because we have a number of use cases, and I'd like right now, like with compute domain, right? Since it's a separate CR, you can't, even if we do this job set implementation, you couldn't provision a compute domain for a job, because this integration wouldn't be sufficient. You'd need to be able to instantiate that CR. So what I'm hoping, and Kevin and I haven't talked about this yet, so this is his first hearing it, but I'm wondering if we could come up with a way where instead of the compute domain CR being a separate CR, it becomes a config in a resource claim template. And then when we do these integrations with things like JobSet, if it instantiates that resource claim, it automatically instantiates a compute domain because it's part of the config. So we haven't really discussed it, Kevin Clues and I, but that's kind of what I'm thinking about for the TPU side of things. I think it would be really cool if the GPU side of things worked the same way.
Mm-hmm. I don't know how that would work, but we can chat about it. Yeah.
Okay. Yeah.
At least from your description just now, but yeah. Mm-hmm.
Yeah. We'll talk about it. I don't have anything written down really for it, and like it's more early forming ideas right now. Dominic's been waiting patiently here.
Yeah. First of all, I'm joining the meeting for the first time after a longer break. So sorry about that, and I left you guys reviews of the DRA coding on the remaining members of SIG scheduling. So sorry about that. And I'm currently working on putting more details on workload hour scheduling. So it should bring settle down some concepts, let us understand how workload scheduling relates to gang scheduling and other things. And this is highly, I think, desired document because many discussions are around that. So I wanted to learn also more about the issue that you are describing. So I'm catching up, and I captured the issue. DRA defining UX for using multiple multi-host resources. Is it something when I can read about the context of the problem that you were discussing?
I think we talk about it some in here.
Yep. Job set issue captures the context. Our use case is inference, but similar concept. Leader worker set would be our priority compared to job set here, but it's the same concept.
Mm-hmm. Okay, so let me read about that offline.
Yeah, I mean, very, very briefly, right? Our normal, on a per node basis, you have a pod, it's got a resource claim template, so we instantiate a resource claim for each instance of that pod. You had a pod spec, right, in a deployment. And this is just taking that up a level, where if the resource claim represents not a single device on a single node, but a device that's shared across many pods and nodes, but you need to instantiate one for each job, say, then this just says, okay, let's create a resource claim template at the job level, for example. You could do it. So that each time that job is instantiated, we automatically instantiate this one shared resource claim that's shared across all the pods. So then you take it to the job set where we're instantiating multiple jobs, and that's where you want the template. It looks more like a deployment and a pod, a job set and a job, but you have to plumb it all the way down to the pod. So that's like 5 sentences or so.
Mm-hmm. So
if you read the doc or read the issue there, I think it describes it better probably.
Sure. That sounds similar to a possible implementation of gang scheduling based on resource claims, but I'm not sure that was the original idea that you were discussing, so that we can have resource claim that requires several resource claim templates in at least that many cardinality.
We could implement, so combining this multi-host stuff with the binding conditions thing, we could implement a form of gang scheduling, and Patrick noted that several months ago. There's an issue out there about that too. So these are all things we could try. I'm not sure that's the right way to do gang scheduling, but it's a possible way to do it.
It's definitely important voice because we have currently a few proposals for gang scheduling, and more we collect, I think it's more valuable to take the right decision.
Okay. Let's see. We have 9 minutes left. Have we covered? I think. Is there anything more on this topic, or I think we can move? I think Praveen's the only one we haven't covered here.
I think this one we can continue offline. Thank you
Okay.
for the discussion.
Yeah, thank you.
Yeah, on the CPU DRA driver side, just wanted to give a quick update. Like, we have like a OSS repo now, like with all of the like whatever we discussed previously. And in terms of like current changes, I'm currently looking into like how we can use like consumable capacity to represent like or to model CPU. I was hoping to have like a demo by today, but like probably by next instance of this meeting, I can try and have something. But yeah, like for anyone interested, like please, you can take a look at the repo and feel free to like suggest changes or like make contributions.
Awesome. Thank you, Praveen. Kevin?
Yeah, I was just curious if you've, I forget how long ago it was, maybe 2 months ago now. Christian from Intel also gave a demo and a presentation on CPU driver with DRA. I'm just curious how aligned you are with him and if you're doing things together or if his is still a different prototype than what you're building or how that coordination is happening.
So like for the design part, it's mostly the same currently. Like uh like the one that Christian showed, it used the existing topology aware NRI plugin and built like a DRA front end on top of that. Even the current implementation that I've shared here uses NRI, and it's kind of interchangeable in a way. Like in the future, if we want to use like the topology aware NRI plugin to do the actual actuation of CPU, that is like totally possible. So yeah, it doesn't use the topology aware NRI plugin, but is like uh is kind of compatible with that. So yeah.
Mhm. Okay. Yeah, just curious. Just want to make sure we're aligned and there's not two of these being implemented in parallel.
Well,
Yeah.
we've had conversations, but then Christian's, I think, was on vacation for the last couple of weeks. And so,
Mhm.
but Patrick, may you actually be able to tell us more about
Not really.
that?
I wanted to add a short status update on DRA in 134. So there was some concern today, quite heated actually, about promoting DRA to GA without having the conformance tests in place. That falls on me. I just went on vacation without finishing that work. And now that I continued it with some PR, the release team got concerned and noticed for the first time shortly before the release that the conformance test coverage dropped again. It's not just DRA, it was also another another API from SIG Storage being promoted to GA without tests. But they singled out DRA particular because I had started working on it and didn't get it done in time.
So the one test doesn't cover all the endpoints?
Yes. Yeah. So we had a longer discussion today, also eventually including Dims and Jordan, and we convinced the release team that full endpoint coverage for conformance purposes isn't really absolutely required and not a reason to revert GA graduation. But it was close.
Yeah.
Wait, but did we convince them? From my
Yes,
reading of
I
the
think-
thread, no one actually said that yet. But yeah, go ahead.
Well, so yeah, I'm happy to weigh in there as well. So that was, I mean, I ran that. I technically is still project owner on that, right? Like I ran the conformance for a long time. So I don't have a problem. It's not ideal to revert, to lose a little, to go away from our 100% coverage. But the reality is we're not doing a good job of making it easy for people to get their conformance tests. Like
That was Jordan's point in the thread.
Yeah.
I think my reading is that the SIG release team has accepted that conclusion from the Slack thread because they stopped arguing against it. I hope that they are not going to come back to it and make a point.
I think honestly, if you tried to revert this, like, well, I guess you could just downgrade it to beta, but yeah.
Not easily, but yeah.
Exactly, not easily. All the control, it would be much more disruptive than just letting it go with a small gap.
The one thing that I was actually more concerned about is that we still had quite a few flakes until very recently, until basically yesterday. Today the last PR got merged.
There were a bunch of PRs that had waiting to merge and they just didn't get milestone. But yeah, now most of them flakes should be resolved.
And there were regressions in our test grid that had not been assigned an issue. I think that was another thing that came up in that Slack thread, that we were actually not on top of all the things that were flaking during the last few weeks. So
yeah, sorry, that's on me.
I don't know. We probably should have really assigned a replacement for me to keep on top of that on a daily basis, and we didn't. It just became a crew effort, and as with all things owned by a group,
Yeah.
sometimes some people do it, sometimes they don't, and no one really is there to fill the gap. So overall, I think we are okay. There might still be one flake left, but it's in the metrics for the kubelet, and that's not GA. So I'm fine with the state where we are right now in terms of getting the release out the door.
Okay, thank you, Patrick.
John, I dropped the link to the Slack thread in the chat here if you want to follow it and or chime in. Yeah.
Thank you. Okay, I think that's it then. Thank you, everybody. And it sounds like we got a lot of things to chat on Slack. So we'll see y'all in a couple weeks.
Thanks. Bye.